Welcome to the third problem of a simple string. So again, we are still on stress and strain diagram. So for this problem, we have different unknown but the same given. So again, the principle is just the same. You're going to derive the stress out of the P here and derive epsilon out as using this delta here. Just divide that by the gauge length of 50, and again this P is divided by the area using the 12.5 millimeter diameter. So we have that pi all over 4 times 12.5 squared. So we obtain these values, and again we graph that one. So the unknown here is modulus of toughness. So we have learned that modulus of toughness is the area bounded by the whole curve below the curve. So using the following the scale of 20 millimeter, in every 20 millimeter there will be equivalent of 50 megapascal for the sigma, and a scale of 20 millimeter equivalent to 0.05 millimeter per millimeter for our epsilon. So graphing that, and then using the same scale, we are going to count now the number of squares. So if you notice here, a certain one square, okay, so a single square here, it was divided into 50 is divided into 2, so the vertical dimension here is 25 millimeter, and for the base dimension following this one, of course we have 0.025 or half of 0.05 as set by this, but we will just use the half dimension to form this rectangle. So we have here 0.025. So all you have to do is manually count the square here. Of course, these little squares here, two of them could compose of the single rectangle. So by doing that, it was counted to be 187 squares. We will just multiply that by the dimension of a single rectangle, that is 25, and 0.025 for the base dimension. So 25 here, we have here a conversion factor equivalent to 1 million, because we need to obtain this unit. So if we are going to investigate the unit, Newton meter is actually joules, 1 joule. So if we're going to have the units here without this 1 million conversion factor, we'll just arrive with joules per cubic meter. Now 1 million joule is equivalent to 1 megajoule. That is why 1 million here is present in order to come up with 117 megajoule per cubic meter. So this is the key to the solution. So again, this is obtained out of the graph, but I would like to reiterate that you can always use the principle of geometrical principle in order to come up with the solution. geometrical principle. So how is this? You'll just have to divide this curve into composite areas, like doing this. Just project this one up to this point. Then you have a triangle for that, under that. And then this one. So there will be a series of composite areas. What are the composite areas? First, we have here the small triangle, in which you can easily determine this by 1/2 base times height. And then another point, see, this is the point, transition point. This is the area for a spandrel. Okay, so remember that the spandrel could have a multiplier equivalent to 1/3 and 2/3. Say this is the spandrel. Okay, so this composes of spandrel. Let me shed that one shade. So if we are concerned with this area, okay, so the multiplier is 1/3 of the base times height. This is the principle. But if we have to use the larger portion, or the bulge curve, considering the other area, the formula is 2/3 base times height. So the spandrel could be the smaller area or the larger portion. So in this case, this is what? The smaller portion. So you could have 1/3 base times height. And then again, you can already project another one here, another spandrel. Again, you can shade that one. So another spandrel here. Okay, you can use 2/3 base times height, or you can actually subdivide that into a rectangle and spandrel. Okay, and then finally you could divide this in spandrel equivalent to 2/3 of the area times the remaining rectangle here. So until you're gonna complete now the total area bounded by the curve below. So that is the geometrical principle. So in board exam, we do not have to do a graphical method because it takes a lot of time. While if you wanted to have a quick solution, you can have by geometrical position, just principle, just the same. You will arrive to a more accurate results. So I think we are done with this problem. So please stand by so that we can start with another problem on simple string.